Does your boss need you to read through countless papers? Does he want years worth of reading and classifying documents done in a single day? Does he constantly say that New Zealand is better than Houston and judge people he just met entirely on their favorite type of meat? No? Just me? Okay. Then let me introduce the solution to all of your document classification problems. Xtract NLP. Hey, my name is Chimaobi Amanchukwu and I am a senior at George Bush High School. I am working with Chard and Tyler Skluzacek on my project Xtract NLP. Xtract is a serverless middleware created to extract metadata from files and folders it is given. My work will be one of the extractors in the main project, which deals with reading through documents inputted along with these folders. There are millions of scientific papers, and currently, in order to classify their topics, people like you must manually read them or use random models which are often hard to implement and understand. People need to be able to input their files of documents and be able to see their topics in an insightful manner. In order to accomplish this, I needed a model which could tokenize the scientific papers and recognize their unique words. Over the 10-week cohort, I tested out a plethora of models from Scikit-learn's cosine similarity to the Spacey community's NUSMD model. The initial models I used, being the cosine similarity and the official Spacey models, had trouble recognizing the words they weren't trained on. They also had trouble providing any insights on papers, which after being classified manually, should have been noted as similar. I thought that the community-made spacing models trained on scientific papers would be the solution, as they could recognize most of the unique words and provide insights on the relationships between words in the sentence. Unfortunately, Spacey's built-in similarity functions could only compare two documents at a time, and even then found some level of similarity even when the documents were vastly different topics. As an example, a COVID-19 document would have a 50% similarity to another COVID-19 document. That same document would have a 40% similarity to a material science document. It worked, but it was not optimal. Xtract NLP now uses Scikit-learn's TF-IDF and K-means clustering in order to accurately predict the topic of the papers inputted without prior programming of number of topics or keywords. All the user needs to do is input their file location and the model will predict their category based on term frequency. Is there any way we can visualize this? Excellent question, Chimaobi. You see, after clustering the documents, Xtract NLP also shows them on graphs. Upon seeing the different cluster, the user can choose to label the graph's axes any name they deem fitting. If need be, there are also three-dimensional graphs which can offer more insights on the distance between one cluster from another, or on outliers and which cluster the model believes they are closest to. I gave the model a folder of COVID-19 and material science papers. The model correctly clusters them into two different clusters based on their term frequency. The data frame shows the model's confidence on which cluster the specific document belongs to. The data frame also shows the name of the file by its category, so you can see which cluster a specific document belongs to. I have changed the axis labels to COVID-19 and material science respectively, and can now see where my documents line on the graph. Although my example is small, it is entirely possible to add your own folder of documents in any size and have the model cluster them to fit your needs. It is possible to customize the model to any amount of clusters you believe it should have, and of course the labels. Xtract NLP is one part of the big Xtract project. As one of its extractors, it adds more functionality and user choices to the middleware. Users will be able to extract metadata and view insights on their topical relationships of their scientific documents. Well, thank you for watching. I hope you had as much fun watching this as I did making it. I learned a lot through this cohort, and I would like to thank the Summer Lab team at CDAC for that. And well, Council Chimobis, I'll see you guys later. Bye.